How does geometric rotation explain planetary orbits? Imagine watching planets dance around the sun in a graceful, continuous motion. Have you ever wondered what makes this cosmic ballet happen? Well, the secret lies in the idea of rotation in geometry. Rotation is when a shape turns around a fixed point, called the center of rotation, by a certain angle. Think of spinning a coin on a table or turning a doorknob. This simple idea helps us understand how planets move in space, but planetary orbits are a bit more complex than just spinning in circles. Planets don't follow perfect circles. Instead, they move along paths called ellipses, which are oval-shaped. These ellipses have two special points called foci. The sun sits at one of these foci, and the planet travels around it. As the planet moves, the distance from the sun changes, making the orbit more interesting than a simple circle. To picture this, imagine rotating a point around the sun at one focus of the ellipse. This rotation helps us see how planets change position over time. The movement isn't the same speed all the way around. When a planet gets closer to the sun, it speeds up, and when it moves farther away, it slows down. This is explained by Kepler's second law, which says that a line connecting the planet and the sun sweeps out equal areas in equal times. From a geometric view, this means the angle of rotation changes at different rates, depending on how close the planet is to the sun. In geometry, rotation involves turning a shape around a point by a specific angle. For planets, this angle tells us where the planet is on its elliptical path at any moment. The shape of the orbit and the changing distance to the sun make the rotation more complicated than just spinning in a circle. Still, the core idea remains the same, turning around a fixed point. Connecting this to basic geometry concepts, the ellipse is defined by two foci and a constant sum of distances from any point on the ellipse to these foci. The planet's orbit can be seen as a point rotating around the sun at one focus, tracing out the elliptical path. The angle of rotation keeps changing, showing the planet's position at each moment. Understanding planetary orbits through geometric rotation helps us predict where planets will be at different times. It also helps in planning space missions and understanding eclipses. This connection between rotation and the elliptical shape makes the complex motion of planets easier to grasp. So, in simple terms, geometric rotation explains planetary orbits by modeling how planets turn around the sun, following elliptical paths that are more intricate than just spinning in circles. This idea links the basic concept of rotation in geometry with the real movement of planets in space.